how part positioning affects build times on our Stratasys J55 PolyJet printer. Today's part will feature this fun, practical door stop. The Stratasys J55 will print this out perfectly. This part features a clear blue, over-molded rubber elastico mix. Look at those sharp, ultra-white Trimec letters. The over-molded rubber provides the slip-resistant rubber bottom needed for the doorstop. Let's first talk about our J55 rotating circular build platen. It's 18 inches diameter, so that gives you 182 square inches of overall build volume. That's equivalent to 10-inch by 18-inch square build area. That's a very large build area. So on the Z-axis of the J55, it's 7.5 inches of build height. So quite a lot of volume there as well. One of the questions we get asked most often, outside of how much room do we have on that circular build tray, 182 square inches by the way, is why is there a pie slice missing out of this pizza? There's a few good reasons for it. We need a gap in the rotating printing process to move the print head and the UV lamp along the lanes. We have 3 print lanes on the J55 PolyJet printer. The inner lane, the middle lane, and the exterior lane. That print head moves on the Y-axis from the center to the mid to the outer lane, and the same process happens with the UV lamp as well. It actually moves on its own Y-axis to cure the layers. Depending on how many lanes are being used while printing, that will dictate how much space is actually missing, the pie slice, out of the machine build tray. So now let's discuss the 3 print lanes on the J55. As you can see on this slide, there are 3 print lanes on the 18-inch circular build platen. The rotating tray, the inner lane, prints the fastest, then the middle lane, and then finally the outermost lane. In general, the inner lane job finishes quicker, twice as quick than the outer lane jobs. The build tray is rotating at a constant speed within the job, but varies between jobs according to the model's position on the tray. The speed of the rotation, the RPM, is determined according to the furthest point of a model from the center of the tray. Look at those 1-inch cubes on those build trays. This is a great example of the time savings for having the same 3 cubes on the innermost print lane. So on the right, it takes 7 hours and 7 minutes positioned in the innermost lane. Now, on the left, the 3 cubes positioned in the inner lane, the middle lane, and the outer lane take 19 hours and 8 minutes. This is a great example of how positioning your parts on the build tray dictates how long it will take to print. Now this slide is really eye-opening. Remember our 3 parts on the inner, the middle, and the outside lane taking 19 hours and 8 minutes? Now, on the right, you could put 38 parts for the same amount of time, 19 hours and 33 minutes. This shows that placements of parts in the build tray really affects the time and part count of your printed 3D parts. Of course, you would use more material with the tray on the right, but the time is about the same. So let's take a look at the door stops we just printed. So on the left, we positioned 1 door stop on the innermost lane, 7 hours and 42 minutes. Now moving over to the right, we were able to position 2 door stops in that inner lane and print about the same time, 7 hours and 44 minutes. So all the way on the right, when we positioned the door stops on the outermost lane, 13 hours and 8 minutes. So you can see by this slide, by paying attention closely to part placement, you could dramatically save part build time on our J55 3D printer. Let's go to the J55 3D printer and see how our parts came out.
Here's our Trimec doorstop. Looks great.